So here are the solutions for the rates and equilibrium practice test 1. This obviously is looking at rates of reaction and equilibrium in Year 12 chemistry. So we need to be first and foremost having the ideas of collision theory in terms of rates of reaction and Le Chatelier's principle in terms of equilibrium position in our heads when we're actually reading through these questions. So here's question 1. A student undertakes an investigation into how the rate of reaction is affected by particle size. They do this by measuring by reacting magnesium metal and hydrochloric acid in an insulated vessel and measuring the temperature increase over the first 10 seconds of the reaction. Below is a table of their results. So we've got a whole bunch of information here as to what happened. Now, we've got a whole bunch of questions here, but I'm going to quickly have a look at what happened in this experiment. You can see that we've got small, medium, and large pieces of magnesium. So that's for the particle size. And then we have a change in temperature over time. So it says the first 10 seconds, but this one's only going up to 8 seconds. So just assume that's what's going to happen here. So what happens is we start off with the small ones. It goes from 22 degrees Celsius here and goes up to 45 degrees. The medium ones start around about 23 degrees, so a very similar initial temperature. That also goes up to 45 degrees, but you can see that it happens slower because the small ones reach 45 degrees earlier. So therefore the rate of the small reaction, that's increasing its temperature a lot faster than the medium ones. And likewise, the large ones, you can see that the temperature increases a lot slower, and it only ever reaches 41 seconds after our 8-second mark. So let's have a look at our questions and work out what's going to happen and how to answer these. Identify the independent and dependent variable for the experiment above. Okay, so the independent variable is what we are changing, and the dependent variable is what we are measuring. So if I go back to the experiment here, you can see that our investigation is about how the rate of reaction is affected by particle size. So our independent variable is what we are changing, and that's going to be our particle size. So particle size is our independent variable, and our dependent variable is going to be what we are measuring or what we want to find out is affected by our particle size, and that's the rate of reaction. You can also think about the dependent variable as what we're measuring. So technically we could be measuring the temperature change, but that is, linked to the rate of reaction. So therefore our dependent variable really should be how we're using that temperature change, and that's an idea of rate of reaction, because that's what my investigation was all about, going back to the first part here. Indicate a variable that would need to be controlled within this experiment. Okay, so what should we control within the experiment? I need to think about what else would affect my rate of reaction. So particle size does, but also concentration of my hydrochloric acid would be affected. So our concentration affects rate of reaction. Also, our mass of magnesium, so our concentration of hydrochloric acid, our mass of magnesium would need to be controlled, because changing the varying mass of magnesium would affect, obviously, the speed at which you would increase the temperature, the rate of reaction. So therefore you have that idea. A few other things that might need to be controlled. We're just looking at temperature change over time, so therefore temperature doesn't necessarily need to be controlled. Ideally, we should have a consistent initial temperature. All right, so realistically, because we know temperature affects the rate of reaction, you probably should have the same initial temperature, because if you're thinking about it, this one here actually has a higher initial temperature, so therefore this might not be a very valid experiment, because our initial temperature would also affect the rate of reaction. If you have a higher temperature to start with, your rate of reaction is going to be faster. So therefore, it's not necessarily going to be the particle size that affects it. So initial temperature should be controlled. And that's pretty much what we have. Technically, you probably should make sure that there's no catalyst present, but I don't think that's really relevant for this experiment in particular. Part C is identify the trend within the results. I haven't written this properly, and provide a reason for this based on collision theory. So what was our trend? What happens as you increase the size of the particles, the rate decreases. So as particle size increases, because that's what a trend is, as one thing increases, what happens to the other one, the rate of reaction decreases. And And remember, our experiment here was all about particle size and rate of reaction. So we want to see the trend between that. So as particle size increases, the rate of reaction decreases. Now, with collision theory, our particle size is linked with surface area. And so therefore, our backing up with collision theory, larger particles have a lower surface area. Therefore, less particles are exposed to collisions, and thus we have fewer shouldn't say fewer, I should say less frequent, because frequency of successful collisions is our buzzword, and that is where we're going to have our answer there. So as particle size increases, rate of reaction decreases. That's directly from what happens in our experiment that I talked about at the start of this. And our collision theory is going through what happens in terms of how do the number of collisions or the frequency of collisions decrease as we increase particle size. Larger particles have a lower surface area, therefore less particles are exposed to collisions, and thus we have less frequent successful collisions. You could write the opposite if you look at the idea of decreasing our particle size increases our rate of reaction, and you just write the opposite part of that there. But this is going back to directly how do you discuss particle size and collision theory, and we should have go-to words. And remember, less frequent or the frequency of successful collisions is what you want to reference every single time you answer this type of question. Next question is comment on the reliability of this experiment above. The reliability is about has the experiment been repeated and do we have similar results for this? So if I have a look at this, I don't have more results other than this. It looks like small has been done once, medium has only been done once, and large has only been done once. So therefore, this experiment has not been repeated, so therefore, we don't have reliability. This experiment has a low reliability, or is not reliable at all, really, because we don't know if we can get similar results next time we do it. Has a low reliability as only one trial has been conducted at each size. And therefore, that's what we want to look at. Reliability is different to validity. If we're talking about how valid this experiment is, you could talk about the fact that it will not be valid because your initial temperature is not consistent across the 3 trials. However, this is about reliability, which is the repetition of your results. As I said, validity is different to this, where you want to make sure that we have controlled all other things that affect rate of reaction. But reliability is all about, have we repeated the experiment? Do we have similar results? In this case, we haven't even repeated it, so therefore we can't comment on if it's reliable because we don't know whether we do it again and we have same results. So that's the idea. I technically, in this one, could write, it could be improved by repeating the experiment, and if we obtain similar results, it would make it reliable, but it doesn't say how to improve the reliability. But you should have an idea about how we can improve reliability. And that's question 1 done.